So we have a test tomorrow. It is going to be a wonderful test.
We're still dropping tests.
I don't think so.
Wait, wait, what?
You guys have such good test grades.
Yeah, but if we get one lower test grade than our grade.
Listen. Don't worry about it.
Higher than 95.
Okay. So we have a test tomorrow. The entire test is on sequences and series. So it's just sequences and series in general. Then there's arithmetic, sequences and series, and then geometric sequences and series. Okay. So, did you guys go home and do the homework on geometric series and do the word problems like I asked you guys to?
I watched Deadpool last night.
That's kind of like doing that homework.
I hope that my book and got started, but I didn't get very far.
I fell asleep.
somehow fell asleep without
It
realizing
was
it.
awesome.
I always thought I was awake, so it was
It's just really hard when you know you have like no homework, but not like homework due the next day, and then like you're like, oh my gosh, I can sleep, and then your body just takes over. Honestly.
I have plenty of empathy for that, and at the same time, I'm like, because some of those questions you guys have never really experienced them before. But anyway, so we're gonna probably spend more time on that than just kind of reviewing. But some of the first, let's see. I mean, some of the stuff at this point you just understand just from doing all the sequences in the series. Like, I don't really think I have to go over too much. Factorial though, real quick, just let's go over factorial. 5 factorial is
5, 1, 3, 4.
5 times 4 times 3 times 2 times 1. 5 factorial over 4 factorial. I don't have to do all that, right? Because it's 5 times 4 times 3 times 2 times 1 over 4 times 3 times 2 times 1, which is just 5, right? Okay, that's good. Okay, what else? We know, what's the difference between a sequence and a series? Series is the sum of the terms of the sequence, right? And, okay, good. Remember, if I have I equals 1 to n of c, that's just cn. Remember these rules. Okay, if I have sum from I equals 1 to n of ci, where c is a constant, I can just pull the constant out. I, right? What was that?
When you go over this today, I wasn't here.
Yes. Okay. C, the reason why this is c times n is, look, I would just be adding up c plus c plus c plus c plus c n times. So it's just c times n. Does that make sense? Yeah? No? The sum of from I equals 1 to n, if for instance, the sum I equals 1 to 5 of 4 is just 4 plus 4 plus 4 plus 4 plus 4, right? Because I'm just counting up to 5, but I'm not changing anything. So that's just the same thing as 4 times 5, which is Ca. Does that make sense? Okay? If I have a constant, I could just pull it out to the outside. Okay? Because, for instance, if I have the sum from I equals 1 to 3 of 4I, that's just 4 times 1 plus 4 times 2 plus 4 times 3, which would be the same thing as 4 times the sum from I equals 1 to 3 of I, which would be 4 times 1 plus 2 plus 3. See that? Does that make sense?
We're getting 1, 2, and 3.
Because I'm just counting up from I equals 1 to 3, right? I is changing. At first I is 1, so it's 4 times 1, then I is 2, so it's 4 times 2, then I is 3, so it's 4 times 3. Right?
Yes.
Yeah? Okay, when I'm doing a sum, when I'm doing a sequence, or a series rather, what's changing is the I. Right? Or if this was K, the K would be changing, right? Does that make sense? So these are the different terms of my series, right? Or my sequence. My sequence, for instance, my sequence could be AN equals N. And then what would the first term of the sequence be? If AN equals N, what's the first term? What's A1? 1. And the second term would be 2, and the third would be 3, right? So my sequence here is just I, right? Or just like N, like that. But the only difference is I'm adding them up. So what a series does is it shows us start from I equals 1, go to I equals 3, and then add them up, right? So it's basically saying go from your first term to your third term and then add them up, okay? That's what a series is telling us, okay? I also have the sum of AI plus BI from I equals 1 to N is equal to the sum from I equals 1 to N of AI plus the sum from I equals 1 to N of BI, right? I can split them up, right? And the same is true for minus, plus or minus, it works both ways. For instance, if I had the sum, if I had the sum of 4I plus 2 from I equals 1 to 3, that would be 4 times 1 plus 2 plus 4 times 2 plus 2 plus 4 times 3 plus 2, which would be the same as the sum from I equals 1 to 3 of 4I plus the sum from I equals 1 to 3 of 2, which would equal 4 times 1 plus 4 times 2 plus 4 times 3 plus 2 plus 2 plus 2. Got it, everyone? You got this stuff, right? Make sense? Yeah?
Yeah.
Ian?
Take a picture of it.
You got it? Okay? You not understanding this? Do you understand the idea of what you're doing with the sum? Yeah? With the series. You understand the sequence, right?
That's with the
The sequence is like the terms of the sequence. AN equals N, or N squared or something, right? The only difference with the series is that you're just adding them up. That's it. Does that make sense? So the sum of 4I from I equals 1 to 3 is just 4 times 1. Because the first term I equals 1, so it's 4 times 1. Second term I equals 2, so it's 4 times 2. Third term I equals 3, so it's 4 times 3. Okay? Okay? And then sum from I equals 1 to 3 of 2, nothing changes, it's just 2. So my first term is 2, my second term is 2, and my third term is 2. So I just do 2 plus 2 plus 2. Yeah? Alright. So that's just the kind of primary definition of a sequence and a series. Pretty straightforward stuff. Arithmetic. Okay, arithmetic.
Sir, how come,
Yeah.
you know how the one that's like N on top and then C and then it equals Cn? How come the 2 didn't change there? How come it wasn't like 3 times 2?
It could have been. It just ended up being 2 plus 2 plus 2, which is the same as 3 times 2.
So you could do that.
Yeah. You got it. All right.
Is there any way you could do it with the other one too?
What was that?
Like the 4i? Or you just have to do it differently because it's like I equals 1, I equals 2, and equals 2.
You have to do that out. But yeah, you have to just like do that. Do the sum. But really, it's an arithmetic sequence, right? Because I'm just, in arithmetic sequence, I'm just going up by a number each time, right? I'm adding a number to it each time. So I'm just adding 1 to it each time, right? So this is where the rules of an arithmetic sequence come into play, right? An arithmetic sequence, I have an equals dn plus c, okay? In the case where it was just like I, then d would be 1 and c would be 0. Does that make sense? Right? But it's an arithmetic sequence, okay? Because I'm just adding to it each time. In an arithmetic sequence, I'm just adding to it each time. So what's an example of this? an equals 2n plus 3. The first term would be what? N equals 1, the first term would be what? 5. And the second term, n equals 2, it's 2 times 2 is 4, plus 3 is, or wait, 2 times
2 times 2 is 4, plus 3 is 7.
Yeah, 7, okay, good. Third term, 2 times 3 is 6, plus 3 is 9. Fourth term, 2 times 4 is 8, plus 3 is 11. You can see I'm adding what each time? 2. That's what makes it an arithmetic sequence, okay? The difference between the numbers, and you guys might remember this, remember it was like if I had two, like some constant multiplied by n, then it means I'm just adding that number each time, right? Yeah? Pick up, whatever you gotta do.
I'm on the way.
Okay, I know, just bring yourself here. Okay, so, you're adding this number each time, okay? So, in an arithmetic sequence, okay, if I want to find the nth term of an arithmetic sequence, for instance, I would say, okay, what's A12? Well, I just plug in 12. 2 times 12 plus 3 is 24 plus 3 is 27, right? Okay, very good. Now, the sum of a finite arithmetic sequence, the sum from I equals 1 to n, a finite arithmetic sequence ends at some number, infinite does not end, right?
This isn't arithmetic anymore, right?
What?
That's not arithmetic anymore?
No, this is still arithmetic sequence.
Oh.
I'm saying the sum of an arithmetic sequence, which is symbolized by Sn, like the sum, the solution is the sum from I equals 1 to n of dn plus c is equal some arithmetic sequence is equal to n over 2 times a1 plus an.
This is for finite sequence?
Finite arithmetic sequence. Finite arithmetic sequence. Okay? When you guys have my word, I'm going to have the algebraic up tomorrow, or the arithmetic one up tomorrow, tonight, before the end of school day, and I'll put this review up as well on my word, on my YouTube. Okay, so Sn equals n over 2 times a1 plus an. So, for instance, if I had the sum from I equals 1 to 20 of 4n plus, or 4i plus 3. Okay? I just have to plug it into this formula basically. Okay? So that equals, what's n in this case? What's n?
1,
The sum from 1 to n, so the sum from 1 to 20. So this n is 20. Right? So 20 over 2. A1, what's the first term? I plug in 1, so it's 7. 4 times 1 is 4, plus 3 is 7. And then an is the last term, so I plug in 20. 4 times 20 is 80,
sorry.
plus 3 is 83. So it equals 20 over 2 is just 10, times 7 plus 83 is 90. So the answer is 900.
Okay, I don't get why. You say the n plus it's 4i plus 3, so why wouldn't it be I?
Oh, I apologize. This should have been I. That should have been I. Make sense? Cool.
We've done ones where I equals something else, right?
I equals like 4 or something like that. Yeah, I'm not gonna do that on test though. I'm not trying to do that. I just want to make sure that you guys know how to do this stuff. What was that? Because it's an, the last term is a20, so I plug in 20. 4 times 20 is 80, plus 3 is 83. Make sense? Okay. Alright. So that was arithmetic sequences and series. Alright. Next, geometric sequence and series. Okay. In the geometric sequence and series, remember I have A2 over A1 equals A3 over A2 equals A4 over A3 dot 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 equals some ratio. So I'm always multiplying it by some ratio. Like instead of just adding like an arithmetic sequence, I'm multiplying by some ratio. So I'm multiplying by 3 each time or 2 each time, whatever it is. And in this case, AN equals A1 times R to the n minus 1.
Is that an example?
What was that?
Oh, it's just like a formula.
That's the general form of a geometric series. Or a sequence, rather. So for example, AN could equal 4 times 3 to the n minus 1. Right? And the third term of this, like A3, would equal 4 times 3 to the 3 minus 1, or 4 times 3 squared, or 4 times 9, 36.
So you're just gonna be like find the
No. That's just an example. But then, I mean, I could. But then what I'm interested more in is the sum for a finite series from I equals 1 to n of A1 times R to the I minus 1. So the sum of a finite geometric series is equal to A1 times 1 minus r to the n over 1 minus r. Okay.
Does that say I minus 1?
Yeah. Because now the n's not changing, the I is changing. Does that make sense? I know it's a little confusing because it's like, I mean, I could just write it like this. AI equals A1 R to the I minus 1. It's the same thing. Right? It doesn't matter what letter's there. Okay? I know it's confusing, but I don't know why necessarily they chose to do it that way and you're going to write it that way, though. It still makes sense, though, right? Okay. Yeah? So these are formulas that you have to remember, is the point. Okay? You have to recognize that it's an arithmetic sequence because it's going to be of this form, right? Like here, and then I know that this is the equation for my sum. I have to recognize that it's a geometric sequence because it's this form, and then I recognize that it's this equation, okay? So for instance, I might ask you the sum from I equals 1 to 4 of 4 times 5 to the I minus 1. You know, because that's of this form, that this is a geometric series. Okay? So then I say, well, the sum is, I find the first term, 1 minus 1 is 0, 5 to the 0 is 1, so the first term is 4. 1 minus, what's my r in this case? 5. So 5 to the n is 4 over 1 minus 5 equals 4 times 5 to the 4th power is 5 times 5 is 25, times 5 is 125, times 5 is 625. So it's 4 times 1 minus 625 over negative 4. Well, that 4 cancels out and just becomes 625 minus 1, which is 624. Does that make sense?
Isn't it 1 minus 625?
It was 1 minus 625, but then there was a negative here. So I made it 625 minus 1. I mean, it would have been negative 624 over negative 1. I guess I put it right now. Negative 624 over negative 1. That cancels and becomes positive. Okay? Those are basically the only things that you just have to remember. You're going to have to remember those. Okay? Well, actually, one more. If I have an infinite sequence, okay, an infinite geometric sequence, sum equals the sum from I equals 1 to infinity of A1 times R to the I minus 1. This equals A1 to the A1, oh, I'm sorry, A1 times over 1 minus R. But when can I do that? What does R have to be?
Less than 1.
Less than 1. Less than 1, not equal to 1, remember. It has to be less than 1. Okay? So, for instance, if I asked you to find, so this is the other thing, the last one. Okay? If I ask you to find the sum from I equals 1 to infinity of 4 times 0.1 to the I power, or the I minus 1 power, well, that equals, what's my first term? I is 1, so 1 minus 1 is 0. 0.1 to 0 is just 1. So my first term is 4. A1 is 4. 1 minus R is what? What's R?
R is 1.
So it's point.
What is
Point
that?
one. R is point one.
Here.
It's got to be point one because if R was one, I couldn't do this. Remember? But do you remember, R has to be less than 1. The absolute value of R has to be less than 1. Okay? Then it's 1 minus 0.1 equals 4 over 0.9 equals what? 4.4 repeating. Okay?
What was that formula for?
It's just like S equals. Zeros are S.
Because it's not like Sn, because it's an infinite. I guess I could put like S infinity, like the infinite sum. What was that, Ivan?
What was that formula for? What's that called?
The bottom one?
Yeah, the one that's boxed at the bottom.
Okay, so this is infinite geometric. Is this one?
Is there infinite arithmetic?
No,
That doesn't make sense.
because I'm just adding each time. So it would never be a number. This is finite, good question. Finite geometric. And this is finite algebraic. Or arithmetic, I apologize. Arithmetic. Okay. You guys all understand this? I mean, it's like conceptually, I feel like you get it. It looks a little bit intimidating when it's all this stuff on the board at the same time. But the truth is just you have to remember these formulas and then just be able to identify them. And it also would have helped maybe if you guys had done your homework a little bit. Because then you would have just been like, oh, okay, yeah, because you would have had a lot of practice. I understand at the same time that probably the first time you realized you had homework was yesterday. So I don't really fault you too much, if at all. So, okay, yeah, a little bit. All right. Now,
So did you just plug in random numbers to that problem?
which one?
To the infinite geometric one?
Like 4 and 0.1? Yeah, I just made up a problem. Does that make sense?
Yeah.
Yeah. Okay. Okay. Now, you'll also remember, you also have to do some, like, things that were on the first homework, like being able to identify a series, like figure out, like if I gave you,
Oh, I suck at that. That was my physical part in the homework.
yeah, I know this. So I'm just gonna erase these.
How many of those do you have?
What was that?
How many of those do you have?
This
This
sounds
is
like
usually
that.
the finding pattern, like
No, no,
the
no.
one we did.
You're also gonna have the stuff that we went over while you were here. The only day that you missed was when we introduced series. Okay. So,
Is there anything else on arithmetic that you didn't find what?
no. So, I mean, it's really just sections 8.1, 8.2, and 8.3. If you go back and look at your homework and finish your homework for tomorrow, you guys are gonna be fine.
What's this called again?
This is just the first chapter, the first section is just identifying the sequence. So I would say identify the sequence.
You just say geometric.
No. You would have to give me like an equals something. So what I realize is, okay, an equals some fraction, where at the bottom, what am I doing?
3 to the n power.
I'm multiplying by 3, right?
Yeah.
So it's 3 to the nth power, right? Okay. And then at the top, what am I doing? I'm multiplying by -2, right? So I could just say -2 to the, would it be n, the nth power? Yeah. Well, if n was 1,
Would it be n minus 2?
n minus 1.
Why?
Because if n was 1 here and it was just 1, then this should be 2. That should be -2. But if it's n minus 1, then I put in 1, it's 1 minus 1 is 0, and that's just -2 to the 0 is 1.
So that's starting at 1 or just starting at 0?
Starting at 1.
Yeah.
Yeah. Yeah, I would tell you that n equals 1 and equals 2, so okay. Yeah, to say assume n begins with 1. Okay, so that's one of them. All right, what about 1 over 2, 1 over 6, 1 over 24, 1 over 120, dot, dot, dot.
What does that first thing say?
Just 1.
So at the bottom.
So what's a good thing to do at first, right? Turn this 1 into 1 over 1, so it makes it easier to look at. Okay, so clearly on the top, I've got some fraction. On the top, I just have what? 1. And then on the bottom, what do I have? Am I multiplying by a certain number? Am I adding a certain number? No. I'm not multiplying by 3 now. What is that?
Multiplying by
3.
It is. It's a special thing that I brought up right in the beginning of this review.
What's going on? It's multiplying by 3, then multiplying by 4, then multiplying by 5.
What is that called? What is it? It's like 1 times 2 times 3, or like backwards, be 3 times 2 times 1. Factorial. So n factorial, right?
Oh,
Okay. 1 factorial is 1, 2 factorial is 2, 3 factorial is 6, 4 factorial. You guys just got to be able to recognize that. That's why I wanted to bring that up. For the record, what's 0 factorial? 1. Good job. And 1 factorial is obviously 1 as well. Okay. Cool. All right. Good. Now. All right. So this is a word problem. This is, sorry. I've got an inverted pyramid kind of thing of bricks. Okay? The top row of bricks has 31 bricks in it. The bottom row has 14 bricks in it. There are 18 rows. Okay, so imagine it's just rows. Rows and rows of bricks. Got it? Okay? There are 18 rows of bricks. The top row has 31. The bottom row has 14 bricks in it. And then the question is, how many bricks are there in total?
The bottom row is 14.
Mm-hmm.
Is this the sigma?
No.
So what's the first thing you should figure out?
The sequence.
The sequence, right? Or like how much it's changing with each row, probably, right? So if it's got 18 rows, it starts at 31 and it ends at 14. How much is it changing each time? By, no, I've got 18 rows. Think.
Wait, don't you start with 14?
I start with 14, I end up at 31.
Yeah, one.
I go up 1 each time, right? I just go up 1 each time. I'll start at 14, I'll end up at 31, right? You can assume that it's not going to be you go up the square root of 3 bricks every time, right? You could just you're gonna add 1 brick each time. You're gonna add 2 bricks each time. If I added 2 bricks, I'd be way more than 31. So the only other option is 1, right? Okay. So I know my sequence AN. Well, let's see. I start with 14. So starting with 14 is a good way to start, right? Plus what?
P2.
14.
You're adding 1 each time, but like,
Yeah.
you can't start 1.
Right. So what I would probably do actually is do 13 plus n. Right? Does that make sense? Because if n is 1, then I got 14, right? Does that make sense?
Yeah.
Okay. So I have 13 plus n is my sum, is my sequence rather. But now I have to find my my series, right? So I want to find the sum from what? N equals 1 to how many rows? 18 rows. And it's 13 plus n, right? Does that make sense?
Yes.
I could use any number. This could have been I, it could have been J, it could have been Z, it doesn't matter, right? So that's my series, that's my sequence. Okay, now, I could add them all up, right? I could do 14 plus 15 plus 16 plus 17. And in my calculator, I could do that, and I could check my answer. But I'm not gonna, if you do that, you could say you did that, and I'll still give you some points. But obviously that's not the point of this question, okay? The point of this question is to realize that this is what kind of series? What kind of series is this? I'm adding 1 each time. A what?
Arithmetic.
Arithmetic. Geometric is I'm multiplying by something each time. So I'm adding 1 each time, so I have to remember. And if I were you, I would remember these, and then as soon as I get my test, write them on the top. Right? I used to do that in college all the time. No one's going to stop you from doing that. Obviously, it's best if you just memorize this, but I tell you one thing, I don't think even I'm going to remember this past 3 months from now. You know what I'm saying? Like I'll remember it a little bit, but I probably have to check to make sure, right? Life is like that sometimes. You can just check. It's okay. All right? So the point is not necessarily to have to memorize these for the rest of your life. The point is to remember how to use them. Does that make sense? Okay. So I remember that I equals, now it might be confusing, I don't want to confuse you, this could be I here, right? So it's, this equals n over 2, what's n in this case?
18.
18, so it's 18 over 2, times the first term. Let's see, first term is 13 plus 1 is 14, plus the last term is 31, right? 18 plus 13 is 31, equals 9 times 14 plus 31 is 45, equals what? 405? Or 4, yeah, 405. Right?
What'd you get for 31 again? Oh, it's just because it's a.
18, right? The nth term, an. So I plug in 18, 13 plus 18. And it should be 31 anyway, right? Because it's my first term is my first row, my last term is my last row. Okay? All right. So
How many more problems are there?
how many more?
How many more problems are there for yourself?
1 or 2 probably. I'm going to give you one that's like a geometric sequence as well. Okay. So I don't have a lot of what could I do for a geometric sequence that's going to be easy enough? Would be like I could say for instance, I have a block, and then the area of the block doubles each time, okay? And the first area is 4, okay? And the first area is 4, and I have 20 blocks, okay? First area is 4, it doubles each time. I have 20 blocks. What kind of series is that? Geometric, okay? So I go straight to here, all right? What's my first term? 4. 1 minus, what's my ratio?
So we don't have to write like that part of it.
Unless I ask you to. But you could do this anyway. The sum of I equals 1. What's n in this case? How many blocks do I have?
20.
20 times the first term is 4. My ratio is what? 2. I minus 1, right? Equals 4 times 1 minus 2 to the 20 over 1 minus 2. And then you just do the math. You guys can do that. Okay? Cool? Alright, good job, guys. Very good. That's good. Alright.
That was close.
You're both still going, sir.
Oh, thank you.